Hi, welcome to ARISTOTHINK. Today I'm going to bring to you the Pythagoras Theorem. I'm going to prove Pythagoras Theorem. Like you know, I like to start with our toolbox because the most important part in math is having a very big toolbox and of course knowing how to use it. So please, let's go to class and let's start to see what should we have in our toolbox. The toolbox is everything you need to know about the properties we're going to use. Now, I'm going to discuss in our toolbox, number one is going to be similar triangles. As you know, imagine we have a triangle, this form, can be bigger. Any triangle. I'm not taking care about, worrying about if they are perfect, similar or not. Imagine they are. Now, we have three possibilities. A, B, C. We should analyze. First, if we have two angles, angle, we can say is a similar triangle. What does that mean? Well, it means that if this angle is the same as this one, and maybe this angle is the same as this one, I can tell you that those two triangles are similar. What does that mean? Does that mean they are equal? No, it means they have the same shape. Maybe this one is a 3, 4, 6, and if they are similar, this one could be 6, double, 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 or maybe 9, 12, 18. You see, they are similar. You can zoom in or zoom out, but they are going to have the same shape, although they are not going to have equal lengths. Now, angle, this is one possibility. Another possibility is work with side, meaning if this side is the same as this one, this side is the same as this one, and this side is the same as this one. If the three sides are the same, I can safely say they are going to be similar. And the other one, and that is the one I'm going to use along with Pythagoras theorem, is side, angle, side. If this side is the same as this one, this side is the same as this one, and any other angle, you could choose to have this angle, this or that. You don't have to have this angle between the two sides that there. No. It can be any angle. Let's for instance give this angle. Let's suppose this angle is the same as this one. Now we have sides, another side, and an angle. That is enough to tell us that if this is 4, 5, 7, and this is 8, I can tell you this is going to be 10 and this is going to be 14. That's what you're going to do. Another property we're going to use, this is a very silly property, is this one. Well, if we have a triangle and we have alpha, beta, gamma, we know that the sum is going to be 180. Now, actually, you should know there's a formula for this. A general formula would be like this: 180 n minus 3. And that should give us the sum, the total sum, right? The sum of all internal angles. Actually, this is n minus 2. I'm sorry. Now take the triangle, three sides. So the sum is going to be 180. Take for instance a square. N is 4. 4 minus 2 is 2, is 360. This is a general form that you can calculate. And this is the formula you can calculate the sum of all inner angles for any polygon. Well, other than this, we are good. Now, let's just go to Pythagoras Theorem, and I'm going to prove to you the formula. As you know, let's erase this. As you know, the Pythagoras Theorem tells us that when you have a right triangle, we know that a squared plus b squared equals c squared. This is no news to anybody. What is interesting, and that is why I want to bring you into this video, is this. I'm going to prove to you, and I believe this is a very funny way to prove. I'm going to prove to you the Pythagoras Theorem. Now, take this square of length 10. So we have 10 squares along each side. And then we're going to make, for instance, every 4, 1, 2, 3, 4, I'm going to create a point, and let's call this A. The purple is going to be A. The length of this segment is going to be 4. This other part is going to be B, which is going to be 6 in all those 4 cases. I'm just breaking each side of this square into 2 parts, A and B. This is going to be A, always A, and the other one is going to be B, always B. Yes, it's just missing this part, right? The hypotenuse, which is going to be C, but is it there? I'm going to get there. Now I'm going to connect those dots like this, like this, like this, and like this. I know it seems, what I want to tell you is this, it really seems that this is going to be a square, doesn't it? And it will be, but it will be, it seems like, is not enough in math. In math we have to prove everything, and that is why it makes so interesting. We know this angle is 9 degrees, agree? This is no news to anybody because in our statement I told you that was a square. If this is a square, we know that all sides are the same and we gotta have 9 degrees angles. Nothing there. Now I'm going to use some properties here. I'm going to start giving some angles. Now, opposite to B is going to be the B angle. Opposite to B, you see? We tend, it's not, if you choose other angles, other numbers, other letters, okay, but we usually give the angle the same letter as the side, the opposite. So, if this side is A, that angle would be A. But let's just put B angle first. So this would be the B, and that would be B. You see, B is always opposite to the sides. Now let's create BA. Opposite to A is this angle, agree? So this is going to be our A angle, and it goes for all of them. Now, something interesting. Remember I told you the property. When you're talking about a polygon, a triangle, the sum of the 3 angles is 180? Exactly. Now, please follow me. A plus B plus 90, because this guys is 9 degree. This is 180. So far so good. That tells us that A plus B must be 9 degrees. Agree? Now, if A and B is 9 degrees. But now look at this part in here. Ignore everything else. I just told you that A and B is 9 degrees. But if this guy is 180, therefore I can safely tell you this is 9 degrees. Agree? It must be so. There is no other way. I told you A and B 9 degrees. But now look. A and B, 9 degrees. This supplementary angle is 90 degrees because everybody must be 180. So with this, I can give a little bit more information about our possible square. Good. But now say, now come on, it doesn't mean it's a square. It could still be a rectangle. Yes, you are correct. we have to prove that those four sides are the same. And we are going to do this. Give me 2 minutes and I prove to you. Let's go this other side, C. Now, remember what I told you, similar triangles. Now, please stay with me. Similar triangles. I'm going to use the property sides, angle sides. Now, please, side, angle, side. Side, angle, side. So I can tell that this triangle is similar to this one. Well, if this one is, I'm going to call this hypotenuse C, I can safely say this also is going to be C. Because this side is locked. Using side, angle, sides, I can not only tell you they are similar, but I can tell you that they have the same length. Because the length comes, the information that I tell you they have the same length is because of the sides. Now, if this is C, this is also C. And you can do to everybody else. This is C, and this is C. Perfect, perfect. Now, I can safely say this is going to be a square. Now, it's almost done. We are almost done. Now, I'm going to calculate the area of everything. And now it's where it gets amazing. Now, let's calculate the area. Area. Okay, now, what is the area of everything? Well, we have this area of this square, and the area of this square is going to be C squared. Agree? Let's continue adding. What else do we have? Now, we have 4. I have proven to you that this triangle, this, and this, I have proven to you that they are absolutely the same length, same size, same shape, everything. They are equal in everything. Now, we have 4. And what is the area of this small base times height divided by 2? So, AB divided by 2. Well, this is one way we can describe this total area. What is the other possible way we can describe this area? I'm going to put in purple. Well, A plus B squared, isn't it? Think about the big picture. This is A plus B. Agree? I told you, at first I told you this is a square. Okay, we need nothing else. Now let's just develop what it's written here and we're done. So C squared plus 2AB. We just cancel those two. Now let's open this parenthesis. This is A squared plus 2AB plus B squared. That guy cancel with this one and voila. C squared equals A squared plus B squared. I don't know about you, but that's why I tell you math is simply beautiful. So it's proved. You see? That's the big picture I wanted to show you. This is the Pythagoras Theorem. Prove it. Hope you like it. If you did, please give a like, because when you give a like to my channel, it shows YouTube that it is an interesting stuff that other people can see, and more people are going to be seeing this. And if you are interested, please subscribe to the channel. My idea is to bring many different curiosities about math and maybe some pinpoint at some specific problems in math, but always with this different approach. So thank you very much for watching, and I hope to see you in the next video. See you soon. Have a wonderful week. Bye bye.